The purpose of this video is to give you kind of a practical summary of the stuff that's in the first 3 chapters of the textbook. And so that's the stuff that we're reading over the first 2 weeks of class. What I'm doing with here is the iris data set, which we saw already in the slides and that you've read about in the book. This also shows us for the first time the Wiki data mining software, which we'll start seeing in class when we meet for the first time on July 11th. What you can see here is if you look at what's on the screen, this is a simplified version of the data set that we have 2 features and then we still have the class, which is the species of iris that this comes from. If we look at what it's telling us up here, one of the features we have is the petal length, and we're actually going to be visualizing this. We're making what's called a scatter plot, which the visualization stuff is for next week, so you'll see more about scatter plots. But we see that it's on the x-axis. So what we have right here on the horizontal axis is the length of a petal from all these different iris plants. Then if we look here, we see on the y or vertical axis, we have the width of a petal. And these are all measurements, so this is numerical data. So the only thing we have that's nominal is the class, which is one of 3 categories. And we see that the point in the xy plane tells us the length. So this is about 4 centimeters probably, and then this is about 1 or 1.1, and then it's colored red, so we see that it's the versicolor species. So we have 2 features shown in 1 class. So what we have here is a way to visualize 3 dimensions. So this is a 3D visualization technique because even though we only have a 2D plane, we're able to see the class. So the purpose of this is to show us the difference between the 4 main approaches in data mining. And those 4 approaches, if I can work this, it's surprisingly complicated, although that worked with 1 click, are classification, clustering, association, and numeric prediction. So this is meant to give us kind of a big picture overview with actual data of what the difference between these things are. So back to the scatter plot here. If we look at this and we want to know, okay, where are the different kinds of irises, because that's the goal of this data mining, is to be able to use the features to actually predict the class or have a model that tells us, given the information in the features, what kind of iris are we dealing with. So the nice thing we see is that, oh, okay, there's one kind of iris way down here, and then we have another kind of iris right here, and then another kind right here. The only annoying thing is that in this region here, they're all kind of mixed together. But if we just take the biggest picture approach we could take with this, we would kind of recognize, hey, wait a minute. There's a bunch of points here that are all for one kind of iris, and then there's a bunch of points here that are all 2 kinds mixed together. And so what we found is that we have 2 groups of data, and we get this just by visualizing. The nice thing is when we have only 2 features in 1 class, it's pretty easy to do the visualization. When we have more features, we're going to have more than 3 dimensions. It gets tougher to do the visualizations. We'll have to come up with a way to do that. But when we put the points into 2 groups like this, what we've done is we've said, okay, we're just kind of dealing with similarity. All these points are close to each other. All these points are close to each other, and then relatively, they're far apart. There's a big space here between them. So when we do that grouping, that's called clustering. We only care about points that are near each other, points that cluster together. And that's indeed what our textbook told us, that if we're trying to group like points together, that's the whole point of clustering. The iris data set can be clustered. We don't have to have just 2 features to cluster. We can have higher dimensions. We can have more and more features and still do clustering. But what we'll see is that we have to be careful if we do that. But clustering depends on this idea of grouping. Distinct from clustering, and now I have to do some erasing because there's a lot of stuff on here now. Distinct from clustering is the idea of classification, and clustering and classification are complementary. With classification, we don't want to look for groups of points. That's the domain of clustering. What we want to do instead is that we want to find a rule that says, given the features, we can say that you're in one class, another class, or in a third class in the case of the iris data. And so what we would do when we would look at this data is we could kind of make the same observation we made with clusters, that, hey, all the blue points are down here. These are all iris setosa. But instead of saying just that these points are close together and that we're going to make a group out of them, instead what we want to do is we want to make a rule. And what we'll see a little bit later in the course is that rules, and this is already in the textbook, but we haven't really dealt with the mathematics or the science of it yet, but rules are going to take the form of something that's a little bit mathematical or something that's a little bit like Boolean logic. And so we can just say, for all the points over here, they're blue, they're iris setosa. And if we want to turn that into a rule, we can say, well, this is petal length of 1, this is about a petal length of 4. If we're halfway between 1 and 4, that's going to be about 2.5. And so a rule for classifying would be that if the petal length is less than 2.5, so that's everywhere on here, then you're guaranteed to be iris setosa. So that gives us a rule for classifying. The difference, clustering has to do with groups, classifying has to do with rules, so that we can, sorry, I got distracted, I got an email. I have to edit that out, except I'm too lazy to do that. Clustering has to do with groups. Classifying has to do with rules that tells us, given the feature, what is the class data. We don't have to have just one rule when we're classifying. We can have multiple rules, but no matter what, the rules will tell us how the features determine the class. So if we wanted to keep going with classification, then we would look at these points and we'd say, okay, we've got the blue points kind of taken care of just fine, but then we have this whole region over here with versicolor and virginica. So we have the green and the red points. And what we would want to do is we want to find a similar rule. It's a little more complicated because if we start trying to draw horizontal lines or vertical lines, we have this one area where the green and red points are mixed together. And that kind of tells us that no matter how we classify here, we're not going to be 100% accurate. That's okay. We want to be as accurate as we can be. So without regard for what the actual answer is, we might kind of draw a boundary like this. We can always think about classification problems graphically like this, is that we're drawing boundaries and everything on one side of the boundary is going to be one class. Then everything on the other side of the boundary will be the different class. That's all we mean by classification in data mining. So through the magic of mouse clicking, I cleared the screen. There's two other learning schemes in data mining, two other kind of big picture approaches that we'll use. One of those is association rules. It's easy to confuse classification and association because they both have rules involved. The difference between the two is that with classification, we're predicting a class value. With association, we don't have to worry about the class value. We're looking for rules between the features. And we can do association rules with the iris set too. The thing we have to watch out for with association rules is even if we find a rule, it might not be particularly useful. It might not help us with classification. That's just something we have to deal with. So the rules take the same form in classification or association. It's just that if we're dealing with the class, then it's classification. If we're dealing just with features, it's association. So if we look at the iris set one more time, and we could say something, let's go back to the same line here, which was petal length less than about 2.5. One thing we can see, it doesn't matter if we move the line. There's a big space between them. So there's a lot of different rules that this data would satisfy. And so if we look at this, it could be anywhere from 2 to 2.5 to 3. And sorry about that. I just had a 6-year-old walk into my office and distract me. So what we could say is that if we want to make an association rule, we could say something like, if petal length, because remember that's the horizontal axis here, if it's less than 2, so if we relate this rule to the class, it's a classification rule, but if we relate it instead to the other feature, then we have an association rule. So if petal length less than 2, then we want to say something about petal width. So here we would predict, well, the petal width, if we look at it, this is about 0, this is 1.3. The petal width, here we are drawing rules again. I'm boxing things in this XY plane we have. Then the petal width is going to be less than whatever this value is here. And I look at it and I'm eyeballing that it's about 2. So we could say if the petal length, and I'm not doing a very good job, it's actually about 1 here. So fortunately I have an eraser. I have this fancy tablet. Look, I erased it. So if you expect editing with this 421, you're not going to get it. It works in all video. So if petal length is less than 2, then we could say petal width is less than 1. So what we've done is we've come up with an association rule. Because it doesn't involve the class, it's just between the features. So the last of the big 4 data mining schemes that we'll deal with is numeric prediction. And we have numeric features here, so we're talking about numbers. We can do numeric prediction. If we just have classes, if we just have nominal data, then it's more difficult to talk about numerical prediction. But when we have numerical features, that's in play. So I'm going to clear the screen here. If we look at this data, even though we have a lot of different points, what I'm really tempted to do, you may or may not be, but hopefully by the end of the data mining course you will be, what's very tempting is to just draw a straight line through the data. And we know what the straight line is going to look like. We know the equation for it. You guys are on the hook for this much math. It's something like y is equal to the slope times the x variable, and then plus some kind of y-intercept. So given this, we could use Excel or we could use the Wiki software or lots of other things. We could find out what the slope is. We could find out what the y-intercept is. If we do find those things out, then what we're doing is called linear regression. And so when we have those values, when we know the slope, when we know the y-intercept, then we can plug in an x value. So let's say we want to pick this. This is about x is equal to 5. We can plug in an x value, and then we can predict, okay, if the petal length is equal to 5, then we're going to get, this is about y is equal to 2, then we're going to get a petal width of 2. That's what we mean by numerical prediction. So that's an overview of the 4 data mining approaches that we're going to deal with the most this semester. This is given an example with a simplified version of the IRIS data set. This is kind of always the way we want to think about data. What we've done is we've visualized it, we've looked at it, and we've said, can we do clustering? Can we do classification? Can we do association rules? Can we do prediction? With this IRIS data set, we can do all 4 of them. That's why it's a useful data set to look at. With other data sets, we'll see that some approaches work better than others, and we have to pick the one that works for our data.